discussing session management. We'll explain listeners in Java Enterprise Edition and filters. Let's start with session management. Here we'll talk about stateless web applications, stateful web applications, and session management and its types. We have learned that web applications are stateless by default since the given protocol, that is HTTP, is also a stateless protocol, which means it does not maintain any state. What is state? Let's assume that we visit a website. Now by default, we cannot expect the website to remember the information that we have entered into the web page when we close the web page and we next visit it at a later date. Hence, a programmer is expected to do some specific configuration and programmatic changes to the application so that the application can remember the information that the user last provided to the web page. It does not allow or provide data access to previous requests during the processing of current request in the servlet or JSP page. In a stateless web application, there is no way to preserve client data across multiple requests. So step 1, the client sends a request to the server. Step 2, the server receives the request. Step 3, the server responds to the client with some information, and step 4, the server closes the connection. And that is where the server will lose any information the client has entered into the server. Going forward, if you need to set up a fresh connection to the server is not expected to remember any information that you last provided to the web application. That is the default behavior of the HTTP protocol. A stateful web application, on the other hand, can remember or use the data of the previous request during the processing of the current request, and hence is termed as a stateful web application. In Servlet API, there are different ways of making web applications stateful so that it remembers client data across requests from the same browser. Making web application stateful is known as session tracking or session management. So step 1, the client connects to the server. Step 2, we create a connection. Step 3, we get a response, and the server identifies the previous request state through session management. So the server knows that the last time the client connected to the server, this is the information that was available, and that information is provided back to the client. The server then closes the connection. Session management is a mechanism used by web containers to store information or session information for a particular user. The session is a conversational state between client and server, and it can consist of multiple requests and responses between the client and the server. Sessions are used for maintaining user-specific state, including persistent objects. The user session refers to a series of user application interactions that are tracked by the server. Types of session management. We have hidden form field, we have URL rewriting, we have cookies, and we have HTTP session. So let's explore the types of session management. The first is the hidden form field. When the server sends a response for one particular request, it sends one hidden field attached to it. The client gets the response with one hidden field, and in the hidden field, the name and value is set as a key pair value. If the same page sends the request the next time, the server can recognize it by getting the parameter of the hidden field. So here is the syntax: input type equal to hidden field, name equal to the key, and value equal to the value. One of the limitations of a hidden form field is that it requires extra form submission on each page. So here we have a browser with a form of a name and address. We send a request. Moment we send the request, it hits the servlet. The servlet then sends a hidden field and name as an attribute, and that hidden field with name and attribute is stored along with the HTML page in the client browser. When we send a request again to the servlet can get that hidden field information and retrieve it. The second option is URL writing. In URL writing, one token is appended to the URL itself as part of the address bar. This token contains one name and one value as a key pair. With the help of hyperlink, the token's name and values are passed to the server. A name and a value is separated using an equal to sign. A parameter name value pair is separated from another using the ampersand. So here we see name 1 equal to value 1. This is one key pair. The ampersand symbol separating the second key pair value. URL writing works with hyperlinks and sends text information. So here we see the browser sending a request to the servlet, and the moment the user enters some data into the page, the second request that goes, the URL is modified with the key pair value. So here you have the name and the value with the second set of name and value. The third option of storing state and doing session management is a cookie. The Servlet API provides Java X.Servlet HTTP cookie class to maintain session. This class extends object class and implements clonable interface. While creating a cookie, a small amount of information is sent by a servlet to a web browser, saved by the browser, and later sent back to the server. Cookie has a name, value, and optional attribute. The browser returns cookies to the servlet by adding fields to HTTP request headers. The cookie has the following information: the name of the cookie, the value, the comment, the maximum age, which is the duration after which the client should not send the cookie back to the server, the domain to which the cookie should be sent, the path, and specifies if the cookie should be sent via the secure HTTPS protocol. So the client sends a request to the server. The server responds along with a cookie. So a cookie is a small file that ships along with the request back to the client, and on the next communication that happens between the client and the server, the cookie is sent along with the client back to the server. The code to construct a cookie with a specific name and value: we have the cookie constructor, which takes the value and the name as a key pair. The cookie class has the following methods: get name, that gets the name of the cookie; get value, that gets the value of the cookie; set max age, to set maximum age of the cookie; and set value, to set value to the cookie. Here we create an object of cookie with the name and the value. We add the cookie to the browser response by saying response.add cookie, so that the cookie information is stored on the client machine. To retrieve the cookie, we create an array of type cookies and we call the getCookies method. We iterate over the array and we print the name and the value that is stored on the client system. The limitations of the cookies are that all data for a session are kept on the client. Hence, corruption, expiration, or purging of cookies can result in incomplete, inconsistent, or missing information. Cookies may not be available for many reasons. The user may have disabled them, the browser version may not support them, or the browser may be behind a firewall that filters cookies, and so on. HTTP session is the fourth option. This is an interface which provides a way to identify one user across more than one page. The servlet container uses this interface to create a session between HTTP client and HTTP server. Servlet can view and manipulate the information about servlet. HTTP session has a method called getSession. The getSession method gets the current valid session associated with this request if create is false, or if necessary it creates a new session for the request. These are the set of methods available on HTTP session. GetMax inactive interval, which returns the maximum time interval in seconds that the servlet container will keep this session open. GetID returns a string containing unique identifier assigned to the session. SetMax inactive interval, which specifies the time in seconds between the client requests before the servlet container will invalidate this session. Invalidate terminates the session and unbinds any objects bound to it. GetSession returns the current session associated with the request. GetSession with a bool create returns the current HTTP session. If no current session create is true, it returns a new session. So here the client browser sends a request to the servlet. The servlet creates a HTTP session object and sets a key pair value as an attribute, and on the subsequent request that comes from the client to the servlet checks if that attribute value exists in the session object. It retrieves the value and sends it back to the client browser. Let's look at a small demo on session management in servlets. Let's go to Eclipse. Now, to summarize what we covered, HTTP is a stateless protocol, and hence if we have a wizard based navigation where we have a series of pages where we are passing data between pages, and finally on the last step of the navigation or the wizard we would want to save that data into a database. Now, HTTP being a stateless protocol, as we discussed, it cannot carry such information from one page to the other. It's only the browser's history object which keeps track of the forward and backward links in our page. Hence, to share data between pages, we need session management. Now, session management has 4 techniques. We saw hidden form fields, which requires a lot of GUI and code, also slows down performance. URL rewriting, where we have to manually rewrite and modify the URL of every page so that we can store information in the address bar. Cookies, which are stored on the client side. You cannot use it to save passwords, etc., because it's not secure. It can also be disabled by the client browser. Finally, HTTP sessions, which creates a unique session ID. It's server-side storage, and the data that you store in a session can be shared across pages of the current session that the user is interacting with the web server. Now, we have 3 types of scopes when we work with servlet. We have the request, the application, and the session scope. So, events that occur between login and logout process of our website is called a session. So, the moment we connect with a web server, the web server creates a unique session ID, assigns it to the client, and identifies that particular client by that unique session ID. And we can also track the login or logout time for the user. Simple example would be that when we go to a net banking website, and if we do not interact with it within the specified timeout interval, the session would expire and we are redirected to the login page again. So let's look at how do we do session management. We'll create a web project and we'll call it session demo. Set the version to 2.5 so we can create a web config file. We'll create a new HTML file in the web content. We'll call it 1.html since we want to simulate a wizard kind of an interface. We'll create a simple form with an action equal to first servlet and method equal to post. So we'll be creating this servlet. Later on we'll say enter first name, input type equal to text, name equal to fname. We create one more input text box which says input last name, and we'll change this to L name. A submit button, input type equal to submit, value equal to next. We'll add another HTML page since we are creating a wizard. Now this will be 2.html. We'll change the title to second. I'll use the form code, paste it into the second form, and here we'll say enter the age, type will be number, name will be age, enter email, type will be email should be number and name will be email, and the submit button would remain the same. We'll add a third HTML page. We'll call it 3.html. This would be the final page in the wizard. We'll change the title to third. Paste the same code and change the fields to contact and city. So we've changed the field name to contact and city. Finally, on the src folder, we'll create a new package. We'll name the package as com. As a convention, it always helps to create a separate package for our servlet. We'll add our servlet, which is first servlet. We'll say next. Next again. And here, like we've been doing in the past, we'll select service and deselect post and get and finish. Now, if you look at the page 1, the 1.html page, it posts to first servlet when I click on the submit button. When I go to the second form or the second HTML page, we'll make this post to second servlet, and the third HTML form we'll make this post to summary servlet. So there are 3 different servlets that each HTML page will post to, and we will see how we can collect the data from each and every HTML page and summarize it into the final page and print it in the last servlet. Now we are accepting individual values from the user, like first name, last name, and here let's change this to contact city, okay, and here age and email. Now instead of storing using session storage individual values like this, it will make more sense to store these values as an object of a class. So we'll create a plain old Java class, a Pojo, a plain old Java object, and we will map these variable names as data members inside that object, so we can retrieve these values, store it into a object of a class, and persist that object using session management. So we'll right click on the src folder and create a new package called data transfer object, or DTO, and within this package we'll add a new class. We'll name this class as user, and we'll add the following code to this class. So we need a first name. This is the information that we were retrieving from the text boxes. Last name, email, city, contact, that will be of type long for a telephone number, and integer age. So this was the data that we were accepting as text boxes. We've created a separate class to store it, and we will create a constructor, default constructor, which is always a best practice when you create a custom class. I'll right click here, select source and select generate getters and setters, select all and OK. So it generates a get and a set for every variable that we created, which is first name, last name. And what we would want to do is we will say generate toString, so that it overrides the toString method and prints all the values available in the class. So here you see it prints first name, last name, email, age, contact and city. This code was auto generated for us, which is very helpful. So it overrides the default toString method and returns all these values on the object of this class. Now let's go to the first servlet, and here we'll import the DTO package dot star. Okay, we'll add it to the end of our stack. So we've imported the DTO package, and within it we have our user class. Now we are interested in the service method. So here let's create an object of the user class, an object of HTTP session request dot get session. We'll import the required package. We'll set the first name by getting the value from the text box that the user enters. So we'll say get parameter fname. So the value that is entered in the text box is stored, and we want to store the last name, so we'll also get the last name value. Using the HTTP session object, we will call the setAttribute method, where we'll create a unique key, and the value to be stored in the session will be the user object itself. Once this is done, we simply send redirect and redirect the user to the second page in the wizard, which is 2.html. Okay, so we create an object of type user, we create a session object, we store the data in the text boxes that the end user is entered into the setName and LName function using the setters. We store that object into the attribute variable of session object, so that it gets stored with the key user, and we navigate to the second page, which is 2.html. Now we'll add another servlet. This servlet will have the name of second servlet. Again, we'll just have the service method and finish. We'll use the code that we had added here, paste it into the second servlet service method, and here we'll pass false to this constructor, indicating that we don't want to create a new session, but the session that was started from the first file, which is the first servlet started the session. We are getting a reference to that same session that is started in the first step of the wizard when the 1.html file posted to the first servlet. So now we need to check if the session is not equal to null. That means an active session exists. Okay, the moment an active session exists, we need to get a reference to it. So we'll create the object u and retrieve the existing user object that is there in that session. So we'll say get attribute, we'll pass the key which is user, and we'll typecast that object as type user so that we are type safe, and store it inside u. We'll now set which are there in the second HTML page. So the user will enter these values into the text boxes. We will retrieve it and we will store it into the same particular object which is u. We'll have to convert this into an integer since we had given age as a int value. So we convert this to an integer, store the value from the text box email into the object u, and age also into the same object, right? So here we are connecting to the same session that is created in the first servlet. We are checking, is that session not null? If not null, we retrieve the user object that is already stored in the session by giving the key, update the additional 2 parameters from the text boxes which is in the page 2, that is the second part of the wizard. Again, set the updated user object into the session with the same key, and this time we will redirect to the last page of the wizard which is 3.html. So this is how the pages will be maintaining the state and moving from one page to the other. We'll add the final servlet, which is the summary servlet, which is relevant for page 3.html. Again, we will select the service method. We'll go to the second servlet. Okay, I'll just remove the declaration again because we've already declared this as a user object. So we'll just go ahead and assign it to the value that comes from the session. Okay, alternatively I could have also got rid of this and created the user object here itself. Now I'll just pick up this code, paste it into the summary servlet. So here as well we want to continue with the same session that was created in the first servlet. So I pass false and get a reference to the same session. We check if the session is not null, we get a reference to the user. Now we'll have to set the city which is on the third form, and we'll have to set the contact information. We'll remove the %, and replace with long dot parse long, because that was a telephone number which is a long value, and replace this with contact. Now once this is done and the object is updated, we'll create a print writer object equal to response dot get writer out dot print line. We'll try and print the values that we retrieved. So we'll say hello plus user object dot get email. So we'll retrieve the email plus close the h2 tag. We'll copy this. Let me add the print writer imports on the top. And we'll print the details. So we just need to print the object u because we had overridden two strings, so it will retrieve all the values for us. And maybe we'll print this in an h3, in an h4. We'll go and print the session ID that we were speaking about. So session ID is session object dot get ID, and we'll also attempt to print session created at session dot get creation time. So this will tell us what time the session actually got created, and before that we will print the session ID. Post that we will destroy the session object, very similar to when the user logs out from the website. We will call the invalidate function, which will invalidate the session. We'll now go to the one.html page. Hit a Control F11. We'll just ensure the session demo is published on the server. And it says enter first name and last name. So we say Amit and Kumar, and we move next. The next step is checking for the age and the email. So we enter some age and email, and the final step of the wizard says give me a contact number and a city. And here you see the entire object printed. Hello Amit at gmail.com, username, last name, email, age, contact, and city. So this information was stored into the session object and retrieved. You see the session ID, and you also see the session creation time, that is the timestamp. So this shows us how we have saved the data into the session. So the first file posted to first servlet, this is where we created the session. We saved some data into it. The second file we trapped data and we posted to the second servlet. The second servlet used the same session object, retrieved the user information stored inside, updated it, and pushed it back into the session, and that's what we retrieved on the final step and simply printed it out. So this showed us how do we actually store session information and retrieve it across various pages in our web-based application with servlets. Let's now move to our second topic, which is listeners in Java Enterprise Edition. Here we'll talk about events in the Servlet API, event class in the Servlet API, and event listener interface. Let's start with events in the Servlet API. Change in the state of an object is known as an event, which occurs during the life cycle of an object. There are important events related to a web application and servlets which are handled by event listener. To be notified of events, a custom class that implements the correct listener interface needs to be coded, and the listener class needs to be deployed via web.xml. The event class servlet APIs consists the following set of classes and interactions with them. So we have the servlet request event, the context event, the request attribute event, and so forth. Listeners are objects that notify whenever any event occurs. They contain event processing logic. The listener interfaces in servlet APIs are as follows: servlet request listener, servlet context listener, servlet request attribute listener, servlet context attribute listener, HTTP session listener, HTTP session attribute listener, HTTP session binding listener. The first one, the servlet request listener, handles servlet request event. It notifies when servlet container is initialized and destroys request object. The servlet container generates servlet request event, which it creates and destroys servlet request object. You have the request initialized and the request destroyed methods available. Then comes the servlet context listener. It handles and processes servlet context event. It receives notification when the servlet container creates or destroys context object. Again, two methods available. Next is the servlet request attribute listener. It receives a notification of the servlet request attribute event. It is used to find out when an attribute has been removed, added, or replaced from the request object. So we have the attribute event, which receives a notification that attribute has been added. The attribute removed function, which is called when a notification is triggered that an attribute has been removed, and then if an attribute has been replaced. Next we have the servlet context attribute listener. It receives and processes servlet context attribute event. Again, you have a attribute added, removed, and replaced method that responds to relevant notifications based on updates for the attributes in servlet context. Then we have HTTP session listener. It receives and processes HTTP session events. This listener is used to find out total active users. You have a session created and a session destroyed, which receives notification that a session has been created and subsequently invalidated. Next we have a session attribute listener. It handles and processes HTTP session binding event. It is used to find out when an attribute has been added or replaced from the session. So here we have attribute added event that responds to a notification, removed and replaced. Then we have the HTTP session binding listener. It handles and processes HTTP session binding event. It notifies when the object of the class has been added or removed from the session. So here we have the value bound method, which notifies the object that it has been bound to a session and identifies the session, and a value unbound, it notifies the object that it is being bound from a session and identifies the session. The last is the HTTP session activation listener. It receives a notification of HTTP session event. It notifies when the session migrates from one JVM to another. The methods session did activate, which notifies that the session has been activated. Session will passivate, which notifies that the session is about to be passivated. Application events provide notifications of a change in state of the servlet context. Each web application uses its own servlet context or of an HTTP session object. Servlet listener configuration. @web listener annotation is used to declare a class as a listener. However, the class should implement one of or more of the listener interfaces. And then in the deployment descriptor web.xml file, this is how you would go and register the listener in the configuration. Let's look at a demo that demonstrates implementing the listener interface to do event handling and handle events. We'll go to Eclipse. Let's close this, and we'll quickly summarize what we discussed and what we are going to attempt in this demo. Now, listeners listen for various events happening within our application. Events are associated with three different scopes: session, application, and request. When there are lifecycle changes for these scopes, an event can be triggered. For example, a session is created or a session is destroyed. And the practical usage of this is they can be used for auditing, like if we need to create a logging framework which will log to a file or log at a central location when the user logs in, and user credentials are accordingly trapped. So we can maintain an audit trail. Whenever some attribute changes within these scopes, so if you have stored some attribute or information within this scope and that value changes or is updated, the event can be triggered. So the events triggered would be when you add, update or replace a attribute value. For example, you cannot have multiple simultaneous logins when you log into your net banking account. The moment you log in, the information is stored in the session or some persistent media saying that this login ID has logged in, and that is tracked. The moment you try to log in again with the same ID, it will give you a message saying that this user is already logged in and does not have a option to log in again since the active session is already in progress. So let's take a small example and see how this works. We'll create a new dynamic web project. Let's call it listener demo. We'll select the version as 2.5. We'll go next and finish. We'll create a new package. Rename it to com. We'll add a new servlet inside the package, and we'll call it test servlet. Again, we'll select the service method and say finish. Let's come to the service method. Here we'll create an HTTP session object equal to request dot get session. So we create a new session. We'll create a system.out.println where we'll just log a message which says session created, listener will be invoked. We print another message which says session attributes displayed, and we'll just say listener to come here. Okay, so the second message. And then let's also let's update the username attribute, so we can have that update event, modified event, and we'll replace this value with Jim instead of Tom. Okay, let me add one more print statement, and here we'll say attribute modified, listener will be invoked. Finally, we will invalidate the session so that the session is destroyed, and we simply print a message saying session destroyed. Now, as a best practice, we'll add a new package. We'll call this as listeners. Within the listeners package, we'll now add a new listener that will listen for events. We'll name this my listener. We are interested in the lifecycle events of the HTTP session object and changes to attributes inside the HTTP session object. Lifecycle events would mean when is the session created. Changes to attributes mean when we update or add the username and password field. So we'll say next and finish. So in the listener, it will actually add event handlers for session created, destroyed, attribute added, removed, and replaced. This is what got added as part of the listener. So let's go to the session created first. Here let's print hello from listener session created at and we'll say new date argument, so dot get session dot get creation time. So this will allow me to trap. Let me add the package java.util for the date class, and that's it. So we just copy this, we go to session destroyed and we say session destroyed. Finally we go to attribute added, we paste here and we'll say from listener key with plus arguments of 0 dot get name, so we'll get the name of the key plus and value is plus arguments of 0, which is a parameter that is passed to this event. So we will be able to do an audit trail as discussed and trap the value, and then we'll just added successfully. So this is an event which will trigger when we add or we remove an attribute. So I'll just put this to the attribute added, and in the attribute removed we'll say removed successfully. Finally the attribute replaced, if we replace or update the value, and we'll make this modified successfully. Okay, so let's go to the test servlet. We'll save all of the information. We'll use a control F11 to run. We'll remove the session and keep the listener demo published on Tomcat. Restart the server. And here you see hello from listener session created. This is the first message that came in with the date time, right? Now if you go to the listener, you will see this was the session that got created, hello from listener session created. And if you go to the test servlet, this is where we created the new session. Then session created, listener will be invoked. So this is the output. The moment we set attribute username and password, it trapped that in the audit trail and it said listener key with username and value Tom and password value Jerry is stored. So if you go to the listener, you can see that the attribute added was triggered and the added successfully got print. After that, session attributes displayed, listener to come here. So back to the servlet, this is the message that got printed. Then we updated username, so the modified successfully event actually triggered inside the listener. Attribute modified, listener will be invoked here. We invalidated. Moment we invalidated, the session destroyed triggered. So if you go to the listener, you see the session destroyed triggered. And finally the removed happened because the session is invalidated, so the data from the session actually got removed. And lastly the session got destroyed, so the session destroyed. So this explains the complete flow of how we were actually able to respond to events using the listener and the events triggered in the right sequence based on whether we were creating the session, adding values or updating values that we stored in the session. And this really helps from an audit trail perspective. If you want to log whether the user is logged in, you want to check what are the credentials of the current user that is logged in. And if you look at the web XML or the deployment descriptor file, you will see that Eclipse automatically configured the listener for you in the config file without us having to really do anything. So that completes our demo in terms of the listener events that we implemented on top of the servlet. Let's come to our next topic, which is filters in Java Enterprise Edition. Here we will talk about why filters, what is a filter, and filters in servlets. So filters are used when there is a need for an operation to occur every time a particular request is made, to perform one operation on other requests in the web application, and to allow one operation to be turned off at deployment. The filter API interface can be found in Java x.servlet package. A filter is an interface used to filter tasks on the request to a resource, a servlet or static content, on the response from a resource, or both. It has three methods as part of its life cycle: public void init, do filter, and destroy. Filters are configured in deployment descriptor of a web application. So here you see the initial HTTP request hitting the servlet container. The request object is created, and before it reaches the servlet that exists inside the servlet container, the filter can be configured to execute. So the filter executes and then passes the request object to the servlet. This is called the pre-processing stage of the filter. The moment the filter responds with the data, this is called the moment the servlet responds with the data, the filter again processes that data, and this is called the post-processing step of the filter. So you can do pre-processing or post-processing before the request hits the servlet, or after the request is returned by the servlet and before it reaches back to the servlet container and then is sent out as a HTTP response. There are different types of filters: the request filter, which contains prerequisite processing logic; the response filter, which can be set as a post-response generation logic; and a request response filter that contains both pre-request and post-request processing. This is how we declare a filter in the web.xml file, and this is how we map a filter in our web.xml file. To write a filter program, we create a Java class to implement filter interface that has following methods: init, it is called once when the container instantiates a filter; do filter, it is called for every request intercepted by the filter; destroy, before the web container removes a filter instance from service, the destroy method is called; and we create one web.xml file to configure the filter. If multiple filters are configured for servlets, they are executed in the same order in which they are defined in the web.xml. So here we have the HTTP request, the servlet container, the request object is created, one filter is set up as a pre-filter processing, then the second filter picks up the request, finally the post filter, and the data is received by the servlet. The response object again goes through the same set of filters, and finally the HTTP response is sent out to the client. This is called as filter chaining, where multiple filters can be set up one after the other and they will execute in the order that they are defined. Let's look at a demo on filters so we understand the concept better. We'll go back to Eclipse and we'll run through a quick summary of what we discussed. A filter can be applied on any servlet or JSP page. The filter can be written either as a pre-processing logic before the request goes to the servlet, and it helps in reducing the load on the servlet or JSP page. It implements the interceptor pattern, which is one of the creational patterns part of the Gang of 4 or GOF design patterns. It is also useful to apply validations and check for the proper URL. If the user tries to ping the servlet without valid data, all such requests can be blocked at the filter level itself. They are generally used for validation purpose and intercepting of the incoming request. Filters can also read the data from JSP or HTML pages and create the object that can be shared with the servlet. The load on the servlet can dynamically and drastically reduce, and servlets can simply take that ready-made object that is created based on the data entered by the user in the UI screens and save it into the database. So we'll set up a new project to explain this and look at how to work with it. So a new dynamic web project, we'll name it as filter demo, set the version to 2.5 so we can create a web XML file and finish. Now filters also have a life cycle like a servlet. So filters, as we saw, they have three life cycle methods: init, service and destroy. That's what we saw as part of the servlet. Now a filter, we saw in the slides that it has init, do filter and destroy methods as part of its life cycle. Similar to the init, service and destroy that the servlet has, a filter would have init, do filter and destroy. Filter can also be connected with another filter which is called filter chaining, and the filters will be executed in the same order that they are created. So to explore this, we will create a new HTML file. Let's call it index.html. We'll add a form, action equal to, and we'll connect to register servlet and method equal to post. Here we say enter PAN number, input type equal to text, name equal to PAN, and input type equal to submit, value equal to validate. We'll save this. We'll create a new package, call it com, add a new servlet, register servlet, that's what our form was hosting to, and we are only interested in setting up the service method. In the service method, we'll create an object of print writer out equal to response.get writer. We'll add the relevant package and we'll say out.print and let us say h4 PAN number plus request dot get attribute, and we'll say PAN, and we'll say plus validated successfully. Okay, and we will close on h4. Make this validated successfully. So here we have set up a filter and you can see it extends, so rather we have set up a servlet with a simple output method which says print. It just says the PAN number. We get the attribute PAN and we simply print a value which says updated successfully. Now to do the validation for the PAN number field, let's add a new package